Okay, let's take this a step further. So we just did this particular example where we flipped 3 coins. What would happen if we flipped 4 coins? Okay, well, what you can do is you can take a tree diagram like this and you can make another set of branches off of each of these. And each of those branches will have a head and a tail. And you can go through that and you can get all the outcomes. And then once you have the outcomes, you can construct the probability distribution. So I think it might be fun to give you a chance to do this. Okay? So what we'll do, we're going to flip 4 coins. And again, let's let x equal number of heads. And then what I'll do is I'll give you a chance to pause the video and see if you can find the probability distribution in this case. And don't feel bad if you're not able to. There's not going to be anything like this I don't think there's anything like this on the homework or the test. But so go ahead, hit pause, and see how you do. And then you can start the video back up, and then I'll show you the answer. Okay, so let's go ahead and see if we can get this. So first of all, I'll put my probability distribution up here because I'm going to need some space for my tree diagram. First of all, the possible values will be 0, 1, 2, 3, and 4. Okay, and so now to make our tree, maybe make this real wide, head, tail. This would be head, tail, head, tail. You get kind of good at constructing these after a while. After you've done it for a while. So that you can get it all to fit, right? Head, tail, head, tail, head, tail, head, tail. And then finally, one more set of branches. Head, tail, 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 head, and tail. Okay, so now let's see if we can list out the outcomes. So we have head, 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 head. So in that case, you really get a head, don't you? Just kidding. Okay, you could do head, 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 tail. Then you could do head, head, tail, head. And then head, head, tail, tail. And you can see that this tree diagram is just a systematic way of listing out all these possible combinations of H and T, right? So now we got head, tail, head, head. And then head, tail, head, tail. And then head, tail, tail, head. And then head, tail, tail, tail. And then we got, now that's the whole upper set of branches. So now we go tail, head, 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 tail, head, head, head. And then tail, head, head, tail. And then tail, head, tail, head. And then tail, head, tail, tail. And then tail, tail, head, head. Tail, tail, head, tail. And then tail, 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 head. and tail, 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 tail. And it takes a knack to do that. It can get a little confusing in there, but after you've done it several times, it gets a little easier. But this is my sample space, and what you'll notice here is there's now 16 outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 outcomes. Okay, and for no heads, that would be this one down here where they're all tails. So there would be 1 out of 16. So for one head, this would be 1, this would be 1, this would be 1. And then I think that there's one more, and this is 1. Okay, so I think there's 4 out of 16. Okay, now what about 2 heads? There's 1. There's 1. There's 1. So that's 3. 4, 5, 6. So there's 6 out of 16. 3 heads. It's going to be this is going to be symmetrical, and you'll see that 3 heads is actually 4 out of 16 again. But you can count them. There's 1, 2, 3, 4, and those are the 4 where you have 3 heads. And it's kind of clear why this would be symmetrical, isn't it? Because you got head and tail, so getting like 1 head and 3 tails is kind of the same as getting 3 heads and 1 tail. And it doesn't matter what you call them, okay? So I don't want to make it too confusing there, though. But this is going to be symmetrical because the coin, head, tail, 50-50, is all symmetrical. And then 4 heads would be this one right up here. So there's 1 out of 16. Okay? So, and then we can make our diagram here. We have 0, 1, 2, 3, and 4. And then we could do 1, 2, 3, 4, 5, 6, and maybe I'll just do 2 out of 16, 4 out of 16, 6 out of 16, just so it doesn't get too crowded there. And so this is 0, 1, 2, 3, and 4. So this will go up to 1. This goes up to 4. This goes up to 6. This goes up to 4. And this goes up to 1. And again, we have a symmetrical distribution. And if I tried to draw this through each one of these, you can see that, again, it has that nice normal shape to it. Once again, it's that nice normal shape. And as it turns out, if I did 5 coins, 6 coins, 10 coins, 50 coins, 100 coins, it'll have this symmetrical shape, and if you draw the line, you'll just fill in this curve, and however many coins, it'll form that nice normal shape to it.